Welcome back, Tinkerbell fans, metalheads, folks watching live, or also friends from the future. Today we're going to look over some of what it takes to develop Tinkerbell, and then tools that the team is looking at to make that a little bit easier. Joining me will be teammate Jason.
Thanks for having me.
Absolutely. Thanks for lending me a little bit of time.
Yeah.
So what's being built for what's being worked on the Tinkerbell project most recently?
Well, so we have a lot of work going on. We're continuing our stabilization efforts. We have some folks that are working on trying to define what building images for Tinkerbell looks like. And I know some folks are looking at how can we optimize the OC experience, the operating system image that we use for basically bootstrapping and running workflows within Tinkerbell. And outside of that, we're also looking at how can we extend Tinkerbell and make higher level use of Tinkerbell to provide, more automated infrastructure management for things. So most recently, we're looking at how do we get things like Kubernetes Cluster API running with Tinkerbell to be able to automatically provision Kubernetes clusters instead of just, how do we run a more simplistic workflow of how do we get an OS on a device, things like that.
Certainly. And then I suppose folks may be joining us for the first time and haven't watched the run up in the series. In the show notes, I'll link earlier episodes where we talk about the difficulties, the how and the why of Tinkerbell. And this in this case, we'll talk a little bit more about what it's taking to develop for Tinkerbell and some of the difficulties there. I think you've got a screen share too that we can drop in there. If folks are joining us for the first time, in a few sentences, what's Tinkerbell and what are some of the best uses for it?
Well, so the most basic explanation of Tinkerbell is basically trying to give declarative management for the infrastructure that backs data centers. Obviously, Equinix Metal, formerly Packet, runs on bare metal hardware, and the folks that have built that have a little bit of experience on how do you automate, this infrastructure, with an API. And the Tinkerbell project is basically trying to take that experience and share it with the community. And how do we bring that kind of Kubernetes style declarative management of that infrastructure to everyone?
Sure enough. And so I've built Tinkerbell and then tested it myself a few times. And so there's many different ways, whether that be if I'm have machines that I'm bringing up in our particular data centers, doing it on the inside virtual machines on the Mac, what's a good way to either standardize that or make it easier? How does your Tinkerbell development environment look?
Yeah, so this was something that was a little challenging coming up to speed on the project. If you go in there, things are a little bit better now. We have the sandbox repository, and I can jump over to that real quick. And the sandbox was a way of how do we get people the ability to spin up a Tinkerbell environment and kind of kick the tires with kind of known good versions. Previously, it was like you just go to the Tinkerbell repository, you run some commands there, and you're running with the latest things. But sometimes, when you're dealing with the bleeding edge of a project, sometimes things break, and it wasn't the best experience for people. So the sandbox repository gave a way for a known version. We have quite good testing around this to be able to just kick the tires on it, and that works pretty well for running things for experimentation, a POC, a demo type of thing. But then when I started getting a little deeper and actually had to try to make some changes, that doesn't necessarily hold up as well. You're back to that same spot where you're trying to run things at the edge of the repo. You mentioned we had a couple of different setups. We have a Terraform setup that'll run on Equinix Metal. We have a Vagrant setup that can run locally on virtual machines. I'm a bit of an oddball in that I run Linux on the desktop. So, I was running the less trodden path with the VirtualBox setup and ended up bumping into some issues related to libvirt versus VirtualBox, some things like that. If we go in, some of the deploy stuff that we have here, and this is in the sandbox. I need to go back to the Tinkerbell repository. There are things like a Docker Compose setup that works really good for testing things within the Tinkerbell repository. But I found sometimes I need to test some things in some of the other repositories. If we go back to the Tinkerbell architecture,
it's a series of pieces, right?
Yeah. There's a few different microservices that compose Tinkerbell, and you have things like the OC boot environment, and all that, and a lot of these live in separate repositories. So if you have to make a change to boots for some reason, and you want to test that change that with some other changes that you have going in Tinkerbell, it started to become very difficult to try to work through how to test these things. And coming from the Kubernetes community and some of the work that we're doing in Cluster API, we had a lot of similar challenges there with trying to test applications or complex systems that spanned multiple repositories. And in the past, we had some enterprising folks that tried out some different developer tooling that's built on top of Kubernetes to sit there and try to do that. And that's how I came across the Tilt project. Basically, Tilt tries to give a tight feedback loop for Kubernetes-based applications to developers so that when you make changes, the images that you need to deploy are automatically built. Those images are then deployed to Kubernetes, and you can kind of test things as you're making changes rather than having to do a lot of work, take the time to deploy those changes and then change them. Basically, as soon as you change a line of code, save the file, it'll automate the process of deploying those things so that you can kind of see what's going on, not quite in real time, but pretty close to real time. And
when saying deploying those things, that can be deploying to the Kubernetes or whatever that you have on your local.
Yeah. It could be a local Kubernetes cluster. It could be a remote Kubernetes cluster, kind of whatever you have. It does kind of assume Kubernetes or some type of deployment experience there. But that kind of got my mind going is could we take something like this and make it work for a project like Tinkerbell? And to cut to the quick answer, the answer is yes. But not without a little bit of jumping through hoops to kind of make that happen. And let me switch over and I can show you kind of what that looks like. If I can get the right window. And what we have here is basically a copy of the Tinkerbell repository. This is a branch on my fork. I still need to do some work to kind of clean things up and try to get it more presentable for upstream, but we can go ahead and share the link to this branch on my fork for folks. But right now, I don't even have a local Kubernetes cluster stood up, so I can just do kind create cluster and then tilt up over here. And this is actually going to take a little bit. There's a lot of stuff going on, and we can go through exactly what's happening there in a little bit. But right now, this is all that it would take to get a whole environment set up for Tinkerbell and be able to start making iterative code changes and be able to test those as you go. just those two commands right there.
Create cluster, tilt up.
Yeah, and let me go ahead and follow this link. And this brings me to the Tilt web console. And this is going to show me pretty much everything that's going on right now. And you can see there's a lot of things here listed on the right. Some of those things are going to be things that you care about developing against Tinkerbell, some of them not so much. As you can see here, there's quite a bit of stuff here. Multis, some stuff related to cert manager, this vert operator thing. Those are all things that were needed just to kind of get some of the machinery going. And then we get into like the DB here. This is the underlying Postgres database for Tinkerbell, Docker registry that's used for some of the Tinkerbell testing for pushing images that are used in workflows. We have the actual Tink server, Hegel. There's this Tink mirror. That's where the OC image is stored and some other bits that are used within Tinkerbell. Boots, another component of Tinkerbell. Some other stuff here related to some of the dependencies. And what we can see here is that not only do we get an overview of the services, and you can see some of this stuff is green. We got a little warning here. We'll see some turn red if something fails. But we're also getting streaming logs from all the different Kubernetes components here as well. And you can click into some of these things and more narrow down to specifics or get an overview of what's going on from everything together. So these are some of the things that I grew accustomed to with the Cluster API project for, being able to inspect kind of what's going on as you're making changes. Because as we all know, with once you get into some more complex systems, it's not as easy to just have like quick little CI tests to verify the overall behavior. You end up having to kind of poke at the system, play with it, and have more comprehensive end-to-end tests to actually test some of the higher level functionality.
Yeah, it's really nice to see everything. I suppose really nice to see everything live updating. Green lights are always nice, but having the looks to be like things that are pending or are still working are the light breathes a bit, and so it's
and to go into some of it, one of the things I was like, originally when I started trying, I was like, well, I can stand up a kind cluster. Could we keep the virtual machines for this type of Kubernetes-based environment outside of Kubernetes? Wherever possible, try not to add any additional complication to your life if you don't need to. And I started playing around with it, and on Linux, it actually worked really good. I could continue using like Vagrant to stand up the worker VM, have all of the applications running in Kubernetes. But I did it with the trick by using the same network bridge between the VMs that were standing up, like the worker VMs, and the Kubernetes cluster with kind. And that worked really good for my setup, but you can't quite do the same thing on say, a Mac or a Windows box. And one of the goals behind trying to do this was, can I see if, we can get some that works for those environments as well? It's kind of funny. Working in open source sometimes is really easy because, you don't have to go through the same type of, things are just out there in the open. You can easily make proposed changes. You have access to the code. You have access to the artifacts. You can do a lot of things with that. But one of the things that you find you don't have is a lot of standardization between the developer environments for people in the community compared to, say, a coding project that you would have inside of just a single company, where you can be more prescriptive of what that developer environment looks like. So Tilt is, a nice way to have a tool that provides some consistency And as long as you don't codify things specifically to an underlying operating system, you can end up with a way to have consistency without kind of forcing everybody to use the same high-level developer environment, even if they're using the same tools. So that led me down, like, how can I solve this problem? How can I get these VMs to talk to things? And then I was like, can we just put the VMs inside of Kubernetes too? And there's a KubeVirt project out there that kind of does just that. So I was able to get KubeVirt running, and first thing I just took KubeVirt, and it's like, hey, can I spin up a VM with KubeVirt? And that worked great. And that's like, can I use this in Tinkerbell? One of the first things I found, though, was I found that I couldn't actually network boot by default with KubeVirt. In order to get kind of pure layer 2 networking working with the KubeVirt VM, you actually have to run a CNI provider called Multis that allows you for chaining multiple CNI providers together, and doing that with a combination of kind of some of the various CNI plugins out there. I was able to kind of get that layer 2 networking connected. And, at that point, it's like, okay, now I have a VM, I have Tinkerbell running, and the KubeVirt VM could actually sit there and pixie boot from Tinkerbell inside of Kubernetes and run workflows.
Yeah, trying to recreate all the things that are going on with hardware in virtual machines has been I've seen be tricky lots of times as the networking.
Yeah.
Dragons.
And I went chasing some rabbit holes too during some testing. It turned out that my desktop, I had followed some directions on my Fedora machine to get Docker working on Fedora, and this was a couple of versions ago. And basically, the directions I followed had me modifying my IP tables configuration a bit, and then turn around and as I was testing, I was like, why is something getting added that it shouldn't be? It turns out it was because I added that IP tables rule, a few months back to get Docker working, and it broke the communication and started adding everything. And it's like, why isn't this pixie booting? Well, that's why.
And then what was the second worst and most soul scarring rabbit hole? If it doesn't take you back to a dark place.
Well, one of the other fun things is I actually had to write a custom CNI plugin for this project to actually make this work correctly. Because once I got everything inside of Kubernetes, it was working great. I was using the standard CNI bridge plugin to sit there and using an IPAM plugin to give out IP addresses. And all that worked great. But I kept hitting that natting issue again. It was natting those requests from that pure L2 network to Tinkerbell, and I was like, or to Boots, and I was like, why is why is this being natted? And it turns out that thanks to it, and I'm not quite sure yet if this is just related to standard kube proxy behavior and how things get routed around in Kubernetes, or if it's some specific to the kind CNI plugin that runs by default in a kind cluster. But the routing wasn't quite working, and it was getting natted. And I was like, well, how do I fix this? So I wrote a quick CNI plugin to basically short circuit that natting and add a rule to kind of poke anything from that interface through without natting. And that was the second biggest rabbit hole for getting this project up.
Looked like the thing that took the longest was the OC. So the OS image is, depending on your network, a little north of a gigabyte.
Yeah, that took a little bit. But now that that's deployed, we can see that everything is finally up and running. And um, you know, if I scroll down here a little bit, we see there's a couple of things down here that stand out in that they don't have um, two green boxes here. Like if we come up here, there's two green boxes, and that basically means that that's a resource that's defined. It is run, which is the bottom box. It last updated and that was successful. And then the top one is that it's actually running and ready, and that's because these ones actually have Kubernetes deployments that are associated with them, and it's actually checking the service here. But some of these are actually dependency um, resources. In some cases, they're built for just the purpose of doing something one-off, like we have these wait for cert managers and sleep until, and some of those slow things down, but they make sure that like cert managers deployed and those resources are ready before we try to use them. So those just kind of like run a command that just waits for some to be ready and then continues. But we have these Tink worker build things. And the reason why we have that is I mentioned before, you can make a change and it'll automatically rebuild the Docker image, push that Docker image, and then run it. Um, Tilt also offers the ability to kind of short circuit that long build process too. So they have this kind of live update feature. And if I pop into the documentation here, if I can find it, there's all sorts of documentation here about how do you accomplish things. This live update reference. Basically, you can sit there and you can define how do you sync these changes from a local environment to the container, and it provides a lot of kind of wiring for you. And we're taking advantage of that. And there's a separate build step, and that build step basically just triggers things to build locally. So if any of the Go files change, it'll trigger the build. And then from that build being triggered, it'll actually just sync just the binary that we built over to the container image and just restart that process. So short circuits the whole need to actually build the container image, push the container image, and then redeploy the Kubernetes deployment to start testing those changes. And to give an example, let me come over here. And there's a couple of places that we're doing this today. I was like, okay, let's take, just that basic workflow. How can we change things? And for some of the components, they are just Kubernetes deployments. The Tinkerbell servers, the Kubernetes deployment, Boots and Hegel, the metadata service, those are Kubernetes deployments. That map pretty easily to the tilt concepts. But we do have a couple of other bits that are running that don't quite map as well. So one of the components that's there is this Tink worker. And Tink worker is basically the component that is run on OC as part of running the workflows. So, you add hardware to Tinkerbell, that hardware is booted up. If it has a workflow associated with it, Tinkerbell basically tells it, go run OC and run this Tink worker. And Tink worker just sits there and looks for things to do from Tinkerbell. Well, this doesn't actually run, as a Kubernetes deployment. So how can we actually make that kind of work? I wanted that same experience. If I make a change to the Tink worker, I'd like to be able to test that relatively quickly. Let me find that here real quick. Similar to how we're doing kind of the Kubernetes type resources, we define a resource here, Tink worker build, and then come down a little bit further. There's this image resource. And basically what this is doing is it's just taking that binary that we just built. It's creating a Docker image for it, and we're pushing it to that Tinkerbell registry that we deployed there as part of the tilt setup. So I could basically come in here, and if I wanted to make a change in this actual worker process, and I'm just going to make a little bit of a white space, change just enough to change the timestamp there. But what we'll see here is we'll have the Tink worker build. That's just completed. And as soon as that finishes, we should see this Tink worker Docker image. Yep, the Tink worker Docker build kicked off. And I might have a bug in the Tink worker Docker push. But that should have updated as well. So I'll have to go and check back on that. But similarly, for like the actual Kubernetes deployments, if I made a change here for the Tink server component, we see that Tink server build completed. And if we come up here, maybe Tink server, it's already updated as well. So any change that I would have made to Tink server would have done that. And because I've also wired up some of these other components too, I can kind of do the same thing with Hegel and Boots here as well.
Having those streaming logs there is real nice. The way I've been working previously has been having either a series of terminal tabs or a handful of sessions open that are watching. But with this, you have whatever it is, the 10 of them that you can just click through.
Yeah, and we can see here, the Hegel service went ahead and deployed. We can see the logs from it starting up and all of that stuff. Now, up until this point, other than seeing kind of those services redeployed, we haven't really done anything with this yet. So let me go ahead and switch back to the YAL so that we can see logs for anything as it shows up. But if I switch back here and consult my quick little README here, we can actually get this set up and going. And most of this is going to be copy pasta here, but this is all based off of the quick start guide for Tinkerbell. And here I'm basically just running the Tink CLI image, and this is just the latest upstream Tink CLI image within Kubernetes. And now I can create kind of the actual hardware that we want to run. And actually add it to Tinkerbell. Did I do something wrong? Yes, I did. Let's try that again. Oh, I think I see what I did. I think I actually copied those backticks.
The comment, yeah.
So let's try deleting that pod and retrying again. Maybe. There we go. Yep, that's exactly what I did. Oh, I copied the front ones too. Yeah, my shell is not marked down. All right, let's try this again. All right, so now I can see I actually really created hardware there. But if I come back here, you can see I can actually see the request that came through. All right. And then just continue with this. And again, this is just from the quick start again, just a quick hello world workflow. This actually doesn't really do anything other than just run the hello world Docker image, and that's it. All right. And actually create the workflow. Copy that MAC address so that I don't have to type it all out.
So what's been done is there's a piece of virtual hardware that needs to be provisioned. A template was created that'll run that Hello World Docker in there, and then you're assigning that template to the virtual hardware that will then get given to it when it asks.
Exactly.
Are there any workflows for me?
And if I actually go and get that workflow, you can see now, as opposed to the template, when we created the template, we didn't actually give it any identifying information there. We just referenced it as .device_1. But when we instantiated the template with the workflow, we told it to map device 1 to the MAC address for the hardware that we created earlier. And when I get the workflow, you can see that it's already done that. Well, like I said, the Hello World, this Hello World workflow is actually just going to run that Hello World Docker image. But right now, that image isn't quite available yet. So this command right here is basically just going to use a tool called Scopio for copying that image to the registry that's running in the kind cluster. And these are things that eventually I would like to get automated with the tilt setup. It's just not quite there yet.
Certainly.
And it may seem weird why I'm actually running these commands like Scopio and things inside of Kubernetes. And that's because part of the setup that I configured with the tilt setup, you have various components like that need credentials from each other or need certificates to enable communication between each other. So all of those are managed through Kubernetes secrets that are mounted in the different deployments and consumed as the different components are talking to each other. So by running some of these things in Kubernetes, it's allowing me to take advantage of those secrets, mount them in the right place, instead of having to snag the credentials from somewhere and then use them locally. And this next one will actually be what actually brings up the actual VM. So I'm going to jump into that before I move on. That's just deploy kind.
And the actual VM. You're talking the new piece of hardware that we're looking to provision. The pretend virtual version of a new piece of hardware that we're trying to provision.
Exactly. And going into this, we can see that this is a KubeVirt resource. It's a virtual machine instance. We can skip over some of this stuff. Memory, we're making sure that it's got at least 2 gigs of memory because the OC image is kind of big and it's going to load that from RAM to actually run the workload. So if we had a slimmer OC image, we wouldn't necessarily need a 2 gig memory VM. But right now, because of OC and having to load it in memory, we do need a little bit of memory. And we're running an empty disk, so no actual disk device on here. It's kind of a workaround for KubeVirt. Generally, if you're running a VM in KubeVirt, you would expect it to have a disk. And then there's this interface stuff that's defined. There's the default interface, which would be whatever normal CNI provider would exist for a KubeVirt VM. But we have that Multus thing that allows us to actually define multiple interfaces, and that's how we get the actual layer 2 networking. So this Tink dev device with the MAC address that we used in the hardware there is actually connected on just a layer 2 network, and we're telling it that that's the first device in the boot order. And the same thing here with the networking here, very similar. We're defining the multiple networks to align with the multiple interfaces there. So going back here, all we have to do is create that resource with Kubernetes. Oh, let me get out of that Scopio pod. So now that we've created that, I can run this kubectl virt VNC worker, and this is actually using a kubectl plugin for KubeVirt to provide that virt subcommand. And here we can see zoom in a little bit. We can see we are now network booting a VM that is running inside of Kubernetes from Tinkerbell.
Excellent.
And just to show, I could come back over here. We have the workflow, and instead of running get, we can run events. And we haven't made it far enough in the boot process to actually start running the workflow yet. So if I come back here, we can see we made it a little bit further along, and in just a second here, we should get far enough that it will actually run. Come on now.
Yeah, you watch it. It takes twice as long.
Yeah. Oh, and I think part of it, I think some of this can be optimized. I think part of the issue right now is I'm not quite sure if this is running with nested virtualization enabled, so I don't know if it's actually being hardware accelerated. And the other bit is I need to see if there's a way that we can ensure that there's enough entropy for the random number generator on boot up. And once those two issues are solved, then we should see much faster boot up times here. But now we can see that it is at the login prompt. So if we run here, we can see the workflow did successfully create. And for example, here, if I need to make a change to the Tink worker, or if I need to make a change to boots or anything, all I would have to do here is basically create another workflow to run. And hang on, sorry, just a moment.
No problem.
I see. I'm in the middle of a meeting right now.
Excellent.
Sorry about that. Pandemic life, right?
Oh, sure. Oh, sure enough. There's
yeah.
I think we get graded on a nice curve.
Yeah. So anyway, yeah, if we needed to make any changes, all we would have to do is make those code changes. And all I would have to do is kind of update, create a new workflow. And because the machine's kind of sitting in a waiting state right now, it would immediately run that workflow. So I can come back in here and basically rerun that Tink workflow create that I ran earlier using the same template, the same device. I created that new workflow through a workflow list. I got a new workflow here.
Yep, that was made 8 minutes later, it looks like.
Yep. If I run the state on there, that one's already run. So any changes that I would need to make would be made almost, almost in real time, and then I can quite easily retest exactly what I was doing without having to worry about, how do I deploy the image? How do I, update things just to get to a state of testing?
Sure enough, I think getting the allowing testing to be done more easily for any of the folks who would like to contribute or try things is super helpful.
Yeah.
Yeah, that's certainly not the way that I was introduced to Tilt, but I'll likely be using more of it in the future.
Yeah, and I did mention that we have multiple repositories. So one of the things that it's been really nice is if I go through this tilt file, there's a lot of things that we're doing here through load. And in some cases, these are actual published upstream tilt file extensions. Like here, I'm saying the minimum tilt version needs to be at least 0.17.8, and that's using an upstream extension. It downloads that extension. That extension, you don't have to worry about that extension being updated underneath you. It actually copy the extension to the repository and commit it to the repository. And that's nice because you control when you update the extensions. You don't have to worry about a change upstream all of a sudden breaking your build or anything like that. But there was a feature added that actually specifically helped us handle the escaping of colons in some component names within kind of Tilt to make mapping these resources actually look quite nice. Lost my window. Okay, yeah. So like if I click on here, there's this facets tab, and this facets tab basically shows me everything that makes up that, all of the Kubernetes resources that are related to it. And if I look here, it shows not just like the Kubernetes deployment, but it also shows me that there's a service account there, a cluster role binding. In some of these, there was like colons in the names, particularly like the cluster roles. And I can't remember exactly what resource it was, but there was one resource where it used it quite prolifically. And because of that, this kind of work needs to have that, that version of Tilt to be able to do it right. And similarly here, it needs to use at least Kubernetes 1.16 to support the CRD resources that are used by some of the components. So make sure that the Kubernetes version is the right version before you start going. So if I wasn't using like a kind cluster for testing, if I was using like a managed Kubernetes provider to test this stuff against, that would have to meet these requirements as well.
Where does the version of Tink that works with it obviously exists if I'm looking at it. The versions of Tink and Boots that work with Tilt and have the required Tilt files and bits of Tilt specific configuration. Where do those currently live?
Currently, they're forks on my repository. Like I said, this has mostly been an experiment to date, and we'll be looking at trying to get these types of things in place upstream. They're not there yet, but also I'm glad you mentioned that because in addition to like the upstream extensions, I've also defined some files in here for like the dependencies, things like that. But there's a couple of library things that I've defined as well. And one of the things is actually around, how do we load those tilt files from the repositories. I wanted to make sure that, as we look at developers, some of the core developers are going to be doing work across multiple repositories. But as we start getting more community members, not everybody's going to need to make changes to all the different repositories. So I wanted to make sure that if they didn't have the repository checked out, you still have like a functional developer environment. So this actually makes sure that if you have the repository checked out and you define where those repositories are via settings, or you can define where those repositories are via settings, and it'll fall back to just using the same parent directory path to where you have Tinkerbell checked out. So if you've defined it and it is present and there is a tilt file there, then it will load it and you get that kind of automatic build behavior for that repository. If not, it'll fall back to using kind of a default configuration that's included in this repository to kind of keep things working.
No, yeah, definitely a useful way to go about, and look forward to seeing that either. It seems like it's will likely end up in the end up as a officially supported way of testing and developing if there's if there's no reason not to.
One of the things we're looking at, and obviously Kubernetes doesn't necessarily make sense for all uses of Tinkerbell, but I mentioned the sandbox repository earlier. We also have a Kubernetes sandbox here as well. And this is probably where the tilt environment is going to end up landing, because this is where we're targeting kind of the Kubernetes deployments and things like that. So I think it'll make sense for the tilt configuration probably to land here rather than in the main Tinkerbell repository. But I'd like to see, are there ways that we can leverage? Because Tilt actually works with more than just Kubernetes. There is ways to make it work with like Docker Compose and some other tooling. So we might be able to still leverage it for like like the regular sandbox-based deployment methodology as well. I think one of the things we're trying to do is move kind of the opinionated deployment type tooling and like the full EDE testing from the Tinkerbell repository itself more towards like the sandbox repositories where it brings everything together.
Yeah, no, that makes sense. What other bits excite you about Tilt? What else have you used that for?
So, like I said, we used it in the Kubernetes cluster API project work, but we're also trying to get some of that stuff working with Tinkerbell today too. And this was one of the other motivations for me behind, how do we get this stuff working for Tilt? I was trying to think ahead, like when we start working on integrating Tinkerbell with things like cluster API, how do we automate that workflow? And if we could leverage like Tilt and tools like that, then we can automate it into the automated tooling that we have for developing and testing for cluster API. And we've started doing some of the work there, enabling cluster API with Tinkerbell. And it's not quite there yet, but part of that work is to try to create more native Kubernetes style resources around Tinkerbell. And I haven't quite wired it up to the full Tinkerbell setup, but we can actually leverage the cluster API Tilt stuff to actually run in the same Kubernetes cluster that we were running Tinkerbell in with Tilt right now. So I can actually spin up a second Tilt instance for Cluster API, and I've already done some legwork to configure it to point to the Cluster API provider that we're building for Tinkerbell, and some legwork there to kind of do the wiring needed. But here we'll actually see that now it's bringing up some stuff. We can see there's a few other controllers here related to some of the other things. We have a nice little warning here. Let's see what that warning's about. Oh, we got a nice little error from trying to talk to Tinkerbell. I think that's probably fine. But now we're actually running what will eventually be the Cluster API provider for Tinkerbell in Kubernetes, and eventually through using some of the different load semantics and everything, I'm hoping that we'll be able to leverage, the Tilt environment for Tinkerbell, the Tilt environment for Kubernetes Cluster API, and merge those two together so that if you're working on the Cluster API for Tinkerbell, you can just run Tilt up, get a local Tinkerbell environment running, a local Cluster API environment running, and be able to start testing there. And there's some additional work going on with the Tilt project to enable like CI workflows and things like that as well. So hopefully that will also be able to give us the ability to not just have developer environments that are running like this, but also have CI environments that are consistent with the developer experience, so that, if somebody's coming in trying to change and the CI tests are complaining about something being wrong, it's a lot easier for the local developer to kind of replicate those tests and then try to figure out how to fix it, instead of having to, try to run the test locally. Oh, it works on my machine, it's not working in CI. What's the difference? And trying to reconcile those things. So the more we can bring uniformity there, the easier it is for users to kind of do the same things that we're doing there. But with that, I can actually show you what this kind of Kubernetes shim layer looks like if you're interested in that too.
Let's see it.
So right now we have, we can run API resources here. If we scroll up a little bit, we can see we have a Tinkerbell cluster, Tinkerbell machine, and some Tinkerbell stuff there. That's all related to the cluster API work, which I'm not quite ready to test yet with the branch that I have locally. Let me see. Where are we? All right, there we go. Okay, we're all the way at the bottom, of course, alphabetical order. We can see we have these tinkerbell.org resources here. We have a hardware, a template, and a workflow, which are the same resources that exist in Tinkerbell. And I have a copy of this test hardware here, and this name actually matches the test hardware that we created previously with the Tilt setup. Oh, why did I do that? That's not going to work. I tried to copy and paste YAML into my shell. That's not going to work. I want to apply that with kubectl. So doing that, I can go ahead and now.
What?
I can go ahead and get that hardware, see it's there. And if I reply or get it and output the YAML, we can see that it's matched up that ID to the Tinkerbell ID that exists already. It's saying that it's ready, and we have some information about it. So it gives us the information about the different interfaces on it, and all of this was stuff that we defined when we applied that to the hardware when creating it in Tinkerbell. And there's some other folks that are working on trying to extend this as well. So you can actually create the hardware resource through here. Right now in this branch, it's just read-only to match it. But I can also create a template, and I'll show an example of that template. It's basically the exact same thing that we created earlier. It's just that hello world example. And now I can go ahead and get that template. I can see that it's showing it's ready. And if I switch back over, not kubectl, Tink template list, I can see I now have a second template called test template here, in addition to the hello world one that I created earlier. So we can see it actually created that resource inside of Tinkerbell for us. And now I think is where it gets a little interesting, because if you remember when we created the workflow before, we had to do a little bit of work to match up that hardware that we created with the template that we created. We actually had to match up, get the ID for the template, use that in the command, and we also had to map the variables that we defined in the template to the actual MAC address for the hardware. Here with the shim, we basically just pointed at the other two Kubernetes resources that we've already defined. So we say we want to create a workflow. We want to use this template, the test template that we created, and we want to use this hardware, test hardware that we created. So now if I create this, and get that workflow, what I can see here is it actually created that workflow for us. We can see the actions that the workflow will do. We can see the actual data that was generated for it. And we can see that the worker is actually specified with the MAC address for the hardware that we created, and all of that. And we can see that the state is pending. It hasn't actually run yet at this point. But if I go here again in Tinkerbell, we can see that the workflow is there. It's created. We can see it's actually success here now because we did have that exact same VM still running and it was still pending and waiting. So if we come back here and look again, we do see that it is successful.
Success. Yep.
Exactly. And what's going on in the background is it's actually watching the workflows, and it will actually update the status as it goes along, so that, as things change, we're updating almost in real time to the changes. We're getting the event streams from Tinkerbell itself. We're updating, and then that will allow us to trigger the updates when we actually start doing the cluster API stuff with Tinkerbell.
Very good.
And similarly, all of this stuff, I'd be able to see within all of the various logs that are being here. So I can see all of the actions that are going on that we found the hardware. Over here, we'll be able to see where, all of the resources were created underlying in Tinkerbell as the actions were run and all of that.
Solid. That brings us real close to the top of the next hour. Anything to leave folks with, or?
I think the biggest thing is if this work has excited you, if you're interested in Tinkerbell, we're interested in kicking the tires, I'll make sure that you have the link so that we can post those in the show notes, and join us and help build cloud native infrastructure management with us.
Yeah, I suppose easiest we'll link it below. But yeah, easiest jumping off spot is simply tinkerbell.org, and has links to Twitter, links to Slack, links to previous videos in the previous videos in YouTube on YouTube in the series, and you can get directly up to speed.
Yep.
Otherwise, we'll see y'all on the next one. Thanks so much.
Thank you.